Welcome to the second video for Section 6, Chapter 1. I didn't change the page yet. This video is going to deal with some additional polynomial-based vocabulary. Again, all of this vocabulary is vital for geometry. If you don't know your vocab, you're not going to know how to solve the problems you read. So, our first set of vocab here is the idea of convex versus concave. Now this again is something we should already know from junior high. But for example here, we're going to look at a pair of octagons. The octagon on the left is convex. What convex means is that all diagonals of that entire shape, every single diagonal, are interior. In other words, and I'm going to draw them all so you can see all of them. If we connect any two vertices that are not already connected, say we start here and we connect it to every other vertex in that shape, all of those diagonals, every single one of them is inside the shape. And we can do the same exact thing from any other point in that shape, and no matter where we go from, all of those diagonals are inside the shape. See what I'm saying? And it really doesn't matter. Like, we could keep going here. We could do every single vertex in the entire shape. Every single one of them is interior. They're all inside that shape. So it wouldn't matter how many of them we decided to do. See what I'm saying? Every single one of them is inside that shape. You get the point. I probably don't need to finish this, but at this point it's beautiful and I feel I need to. So if we look, we have all of these diagonals and every single one of them is contained entirely within that octagon. Now, on the other hand, this is also an octagon. It has eight sides, but it's dented, right? It's caved in, concave, caved in, okay? In other words, if we can draw even one diagonal and have it be outside the shape, then it's not convex, it's concave. So for instance, if I connected these two vertices, that diagonal is outside the shape, right? That makes it concave. It is outside the polygon. It's still a polygon. It's just a concave polygon. Okay. Next up, we have a couple of other phrases that deal with polygons. We have the term equilateral, which is where all sides of the polygon are the same length. So I have two examples here. I've got a square where all four sides are equal. And I've got a decagon, because it was important that we show one that was concave but still equilateral, where all 10 sides are the same length. That is an equilateral polygon. We could also have what are called equiangular polygons, where all the angle measures are equal. In other words, all of the angles are congruent. So my example for that was a rectangle, because that rectangle is clearly not equilateral, but all four angles are 90 degrees, which means it is an equiangular polygon. And then if we have a polygon that is both equilateral and equiangular, that is a regular polygon. So equilateral and equiangular. That would be considered a regular polygon. That will do it for our second video. We have one video to go in Chapter 1 covering area and perimeter.